Hey, good afternoon, everybody. We're going to do a couple of examples here today on Pythagoras' theorem. It's something I think that a lot of you will hopefully remember from back in grade 9. But we're going to kind of back things up a little bit to showing you how to use your calculators to figure some things out. And before we get started, I want us to just think about a couple of things. If you had a question given to you where you had 2 times something equals 10, how do you figure out that something? What do you do with the 2 and the 10 to give you the answer of 5? Because we know 2 times 5 is 10. And the answer that I'm looking for is that I want you to tell me that while you would take 10 divided by 2 and the answer is 5. And then we could have said, well, what if you had a question that was like x plus 7 equals 11? And we might know already that the answer is 4 because 4 plus 7 is 11. But how do you work the 11 and 7 to give us the answer? And the answer is you subtract the two numbers. So what I'm trying to lead us to here is the fact that when we go to solve some things in math, a lot of times we have to know how to do opposites. When we have a question that's 2 times something, we divide by 2 to get our answer. When we have x plus 7, we subtract 7 to get our answer. So that's the kind of thinking we want us to have as we go through our questions with squares. We're supposed to find the area of this square. And in one way we can just count the squares. And you look at this picture and there's 9 squares in there. So this has an area of 9. And for better or worse, I don't know, I'm going to say that's 9 centimeters squared. So there's 9 squares in there. But what we don't want to have to do as the questions get bigger, we don't want to have to count. So what is the mathematical process that you use to figure out the area of a square? And the key thing is, this is for a square. And we know that the length and the width are both 3. So to find the area of the square, what I really want us to understand is that you take the number and you square it, which means you multiply it by itself. And that answer then is 9. The same thing would be true on the next question. If we just talk about area before we kind of go back to the second part of the questions, I can count. I know there's 16 squares in here, and when I look at my square, maybe it's 4 centimeters by 4 centimeters. So how do you find that area without counting? The area would be 4 squared, which is 16. 4 times 4 is 16. So one of the things that we have to be able to do in our math class is we have to be able to square things. We have to know how to use the squared button on your calculator, or else know how to multiply something by itself. So this is where the going backwards comes in now. What if you started off with a question and you knew the area was 9? How long do the sides have to be so the area of your square is 9? So I just want you to kind of think about that and maybe think about a reverse operation that you could use with 9 that'll give you the answer of 3. Or what is that same reverse operation that you use if you have an area of 16 and the answer is supposed to be 4? So we know the answer is 3 because it's in the diagram. 3 times 3 is 9. We know this answer is going to be 4. So what's the math that we can use to help figure these things out? And it kind of goes back to the idea that if you have length times width and it's a square, x squared equals 9. And what is the opposite operation of squaring? And when I was working with the first group, they kind of got stuck on this. But the answer is you want to square root. The opposite of squaring is to square root. So if you can find the square root button on your calculator, you take the square root of 9 and the answer is 3. Now, if you didn't get a calculator today, you want to come up here and get a calculator again from the desk, that's a good thing to do. The calculators that we have for you to use, if you want to find the square root button, you have to do a couple of things. Our square root button is actually, it's a 2-button process. You have to press the second button, and if you look at your calculator, you got to press the pi button. If you press second and then press pi, what comes up on your calculator is like a check mark. It's really supposed to be a square root sign, but it looks like a check mark. So if you, again, if you just press second and pi, and you get that little square root symbol, if you take the square root of 16, and just when we write it, we should write that a little longer just so it covers the number. Again, if you say x squared equals 16, x equals the square root of 16, you get the answer that x equals 4. So what I want us to see when you have the diagrams right there in front of you is that the opposite of squaring something is to square root it. And we can square root squares to figure out the length of the sides. If there's at any time you guys you want us to pause the video, you can just ask to pause the video. Mrs. Wrightsma can pause it for us, and or if you want to go back and check this is posted. It's a shared document as well in our folder. You can go back and play this. Let's apply these skills now to things where you don't have the diagrams drawn. But when we're doing questions, we're going to do triangle math for the week here. We want to be able to draw a diagram. So why not draw a little sketch? It's a square. It doesn't have to be the perfect square. You don't need to put 6 lines in by 6 lines. We just need to know it's a square. And the sides of the square are both 6. So how do I find the area? I'm going to square 6. So this area is 36. And because I have centimeters in here, I'm going to say there would be 36 squares for that answer for A. It's no different than looking at the floor and knowing if you have 6 rows by 6 columns, you'd have 36 square tiles on the floor to kind of give you the area. For B, this one is an example. Now, a lot of times in math, we do things, we don't have nice numbers to work with all the time. You know, we try and work with nice numbers to make our answers work out for us, but every once in a while we get questions that we don't have great numbers with. So we get a question like this. The area now is 3.3 squared. So decimals are okay. We can have decimal answers. And if you take that and you square 3.3, you get 10.89. Now, we don't usually write a whole bunch of decimals for our answers. Quite often the questions are going to say round off to 1 decimal place or round to the nearest tenth. So our answer that we're going to go with today is we're going to say this is 10.9 centimeters squared. And that's finding the area of a square. Now we're going to work backwards. Again, if we want to kind of visualize what we're talking about, what we're saying now, inside the square, we have 121 little squares. Exactly 121 little squares are inside this shape. How do you figure out the length of the side? Well, we know the area is 121. We know that x squared is 121. So just like we did on our first examples when we had the boxes, we know the opposite of squaring something is to square root. So if you square root 121, so again, if you go second pi on your calculator, square root of 121, you get an answer that is exactly 11 centimeters. So that's kind of nice when things work out to be whole numbers like that. But kind of like what we did in B in the last one, we're going to do the same thing here for B on the next one. I'm going to have a square, and inside this square are 70.6 centimeters squared. So it's not even like a whole number of squares in there. I don't even, I got a chunk of a square. But however all those pieces go together, what I know is that when I'm done, it made a square. It's not a rectangle, it's not a circle, it made a square. And again, I don't know how long those sides are, but I do know that if I multiply them together, length times width, I get 70.6. I know my area is 70.6, which means if I'm going to find the length of the side, I'm going to go square root of 70.6. And when I get this answer, square root of 70.6, I get a whole bunch of decimals with this. So if you kind of did that on your calculator, you get 8.40238, and it just kind of keeps on going and going and going. I mean, it stops on your calculator, but actually the numbers don't stop. So the same as we did in the previous question for B, let's just say that this is 8.4 centimeters. So there's the first page of our notes. Can you use your calculator to square things to find area? And can you use your calculators to take square roots when you know the area to find the length of the side?